So we're still in 6.2, and now I'm on page 324. The part I want to talk out loud to you about is finding data values given specific probabilities. We're now going to go backwards. You've been looking at where I left you in the overview to draw, convert, and find. You were doing the direct route on those earlier problems. Now we're going to turn around and go the other way. Yay! So right here is how we're calculating our z-score. You will see me still use this to calculate what we're about to do. I like doing it. I like using the algebra to find it. But the nice thing is they've already done the algebra and they've given you a formula. So here's a formula. And I would grab your formula card and I would go to chapter 6. And on chapter 6, you've already gotten your, sorry y'all, you already have your z-score written for a population or for a sample. I would write in somewhere on here the shortcut to what we're about to do. You don't have to. With the z-score on there, that formula is going to get you everything you need. But if you want to cut out a few steps, go ahead and write this one on there. Where the data value is going to be the z-score times our standard deviation plus mu. Again, you're going to see me start here sometimes. Sometimes you'll see me use this one. I'll do both. You've got to figure out which one you like for you. There is a procedure table. Again, I'm asking you all to draw for points on the test. So we're going to draw. We're going to find the z value that corresponds to the percentage, the probability that they're giving to us. And then we're going to calculate the x, the one that we're looking for, and they want us to use this formula. But again, I may go back to the z-score formula and just work it all the way through from there. And it doesn't matter. You might want to use that on a test to use one way to solve it, and then when you go to check your information, go through the back door and do the other one. So I'm now looking at example 6.9. I'm on page 325. And see if you can see the parts that are different or going backwards than what you've been doing in the videos that you've been watching. To qualify for a police academy, candidates must score in the top 10%. They're now giving us our probability. They're giving us our percentage on a general abilities test. Assume the test scores are normally distributed, and we already mentioned that earlier. From now on, assume that, but they'll always write it. And the test has a mean. Aha, we have some information. It has a mean of 200. I would mark it up. And then it has a standard deviation of 20. Find the lowest possible score. We're going to be looking for x. So they gave us the percentage, and then over here it said draw a picture, find the z value from the table that corresponds with the desired area. We've got that 10%. We're going to have to do something with it based on what we learned in 6.1. They go through some information. I have, the cool thing is, everything that we had in class that y'all saw me keep referring to, you now get to see what was going on in my book. Here's where I start with the z-score. Here is where I plug in, wait, where'd this 1.28 come from? So let's just go back here to the z. The x value I'm looking for minus the mean, which is 200, over the standard deviation, which is 20. So that's where I started, but I should have started with a drawing, and I don't even have a drawing, so I'll just use theirs. They just mentioned that we are looking for the score that means you are in the top 10%. 10% also means 0.10. But when we go look at our z table, everything's going to have 4 decimal places, so let's go ahead and see it as a 0.1000. And when we get to the table in just a minute, I'm even going to suggest that you ignore the decimal and just look at it as the number 1000. I think that might help your brain to see which numbers we're closer to when we end up having a contradiction. Or not a contradiction, but a choice of which way to go. So I have a 0.1000. But my chart is not for the information on the right side of the z, it's on the left side of the z. So to go find the accurate z-score, I don't need to know this 0.1, I need to know 1 minus my 0.1. In other words, right here, I'm going to go be looking for 0.9000, which is 9,000. And so when I look on my chart looking for 9,000, if I really look at it as 9,000, I notice here I've got 8,997, which is 3 points away from 9,000, and that's 9,015 is 15 away, so here's my winner, this 0.8977. So I look over here and I'm at 1.2, and I look up here and I'm at 8. So the z-score I need is 1.28. And you'll notice that's what I put in over here. I like to do the algebra, and so to do the algebra, I keep moving my pins around on myself. Up here's one. I'm going to multiply both sides by 20. In other words, I just multiplied by the standard deviation, and you'll notice here that in the formula, you're probably going to want to use, you take the z-score and multiply it by the standard deviation. Well, that's what I've got going on up here, my z-score times my standard deviation. And when I'm looking at this algebraically, this minus 200, I'm going to need to then add it to both sides, and that 200 was my mean. So if you want to see it algebraically, we're going to end up with an x value of 225.6, 225 and 6/10. If you don't like my algebra, then all you got to do is come down here, punch in the z-score we just got, times your, standard deviation, and then add in the mu. Just make sure that you're smarter than your calculator. Use parentheses as needed. Either way we go, we're getting this 225.6, and then you got to figure out what to do with the answer. And I would look on the test to see where I'm asking you to round it to, or you just make a choice and round it accurately. At the very bottom of the page, it says a score of 226 should be used as a cutoff, and anybody scoring higher than that qualifies for the academy. We've answered the question at the beginning that said what score. If you're not clear on what we just did, this is a great place to pause, go back and look at all the information, and start and stop the video until it makes sense to you. So now I've turned the page and I'm on 326. I want to walk through example 610 with you. And it's very similar to what we did, a little bit more complicated because, as you can see from the drawing, we're going to end up with information in 2 z-scores that we're going to have to go find. But we just are building on what you've already seen. I'll go ahead and read the question that for a medical study, a researcher wishes to select people in the middle 60%. And so you're thinking, how am I going to recognize this on the test? What's it going to make sense? What will help make it make sense in the middle of the test? And when you see something like middle, that tells you your drawing is going to look like it's going to have a lower number and an upper number based on blood pressure. Assuming the blood pressure readings are normally distributed, again, we're going to assume everything we're doing is, but they still have to say it. Find the mean systolic blood pressure. The mean systolic blood pressure is 120, there's our mean, and the standard deviation is 8. Find the upper and lower readings. In other words, we need the x at the bottom, and we need the x at the top of that range. And to get x, we're going to repeat the process we just did in our last problem. That would qualify people to participate in the study. So they're looking for people within this range. It says draw. And so when we go to draw, we are looking for some x value at the bottom and some x value at the top. When it says it's in the middle 60%, our mean is somewhere here in the middle, which our mean is the 120. It says find the values, blah, blah, blah. And so we're going to have to do some calculations. But to do those calculations, back over here, At the bottom it said draw it. Let's go find some z values, and then we'll calculate the x values. Z values are going to be a little complicated, but again, you can start and stop this recording as much as you need to. So we just kind of drew, and then we're going to look for z values that correspond to the desired areas. I like their drawing because it has shading. And so if you notice here, they want the inner 60%. And I'll go back to the question that said the middle 60%. So if they want the middle 60%, you've got to envision that there are 30% and 30% on each side. And if that's the case, dead center z-score is a half. The percentage, the probability, the score is a 0, but its probability is half, 0.5000. And so if we're going up 30%, then up 30% will put this one at 0.8 or 8,000. I just added the 0.5 and the 0.3. That gets me the information I'm going to need for my upper x. And sorry that I relabeled or labeled mine differently. We just need them to be different. And it doesn't matter that one's an x sub 2 and one's an x sub 1. I'll go ahead and change mine because I don't want any confusion. Doesn't matter though. And this x down here, what is going to be the area, the location, the probability that it represents? Again, if dead center is 0.5, then we're going to take away that 30% up here, and that'll get us at 0.2. There was one sentence I didn't mention on this page that I had highlighted. And I'm back on page 325, about halfway down the page, and it says if the area that we are looking for falls exactly halfway between two z values, use the larger one. A while ago when we looked at this one, it was a lot closer to the 0.8997, so it wasn't exactly halfway. But we are going to have some that fall exactly halfway, so make that note in your notes or on a flashcard or whatever works for you. But right here, I now have two probabilities that I've got to go look up on my table. And so when I go to my table at 0.2000, I don't see 0.2 anywhere on my positive side. And that makes sense. I'm to the left on the bottom side of half, so my 0.2 is going to be on the negative side. Again, I think it might do you better to not see it as a 0.2, but to see it as 2,000. And if you see the 2,000, I'm looking for 2,000, 2,000, 2,000. Okay, right here. This is like 2005, and this is like 1977. So this one's the winner because I'm 5 away from the 2,000 that I need, and it's a -8. And -8, and up top is 4. And so you'll notice they've already calculated this in the book. Where is it? Here it is. For the 0.200, we're at -84. Now notice what's going to happen on the other one. On the 8,000, I need to go to the positive side, and when I'm looking for my 8,000, I'm scurrying along. Oh, here we go. And right here, this is like 7,995, which I'm 5 away from my 8,000. This is 23 away. Don't want it. And notice over here, I'm at 0.84. Wow, does that sound familiar? And remember, our distribution is symmetrical. So there's a quick double check for you. One's going to be positive and one's going to be negative. Now that we have our z-scores, we're going to go plug them in our respective formulas. Some of you may like using the algebra. Some of you may want to go straight to the formula that they're saying, hey, use the shortcut. So I did one of each. On the top one, I'm using the .84, which was for the right hand, the one over here at the 0.8. I have my x, I have my mean and my standard deviation. I multiplied both sides by 8, and then I added the 120, and I get 126.72. And that's what they got, 126 and 72 hundredths. If you prefer to use the formula they've given you, just a straight plug and a straight chug into the calculator. Here's my negative 84.84. Again, here's our same, standard deviation plus our same mean. That calculation gets us 113, and it's on here somewhere. Here it is, 113 and 2800ths. So the ending statement says, these numbers, and I'll put them here, this one would be 113, and this one's about 127. So the people who would fit in the range of the study will have the systolic blood pressure between 113 and 127, and we have our closing statement. Therefore, the middle will have blood pressure readings of, and notice they left it at the hundredths. I made it on into, converted on over to whole number. Watch the test. If the test says nearest hundredth or nearest tenth or whole number, do what it says. And if I don't mention what to do on the test, then you just round correctly. That finishes this chapter. I know there's more to do, but you probably can even see right here that I didn't do the rest of this in the fall, and we ain't doing it for this semester. So you have some homework. Just double checking here. Yep. You have some homework to do, and it's all listed in the list of assignments that I've sent to D2L.